Today we will talk about decorators in Python, what it is, how to use them and how they work. I am going to start with creating of a background for decorators demonstration. And as you may know, list comprehensions work faster than creating lists via for loops. It's true, but I'd like to check this fact in practice. And to do so, I will write two functions. One of them will use a for loop to fill an empty list with even numbers in range from 0 to 10,000. And the other functions will do the same with the list comprehension. Then we will measure the time and see what function works faster. This activity will create the context, and at the same time we will approach the problem. Let's create the first function. I'll name it, let's say, 1, and then I'm going to create an L variable that equals to an empty list. Then I'm going to start a for loop. For each I in range 10,000, here function range with 10,000 as an argument will generate a sequence of numbers from 0 to 10,000, obviously. Then I'm going to check if the I variable is divisible by 2 entirely. I can do it with the %sign, which is called modulo, and modulo returns a reminder of the division. For instance, 10 divided by 2 with modulo returns 0, and 5 divided by 2 with modulo returns 1. And if the remainder of the division by 2 is 0, it means that the number is divided by 2 entirely, and the number is an even number. So, if I %sign 2 equals to 0, and if this expression returns true, it means that I variable on an iteration of the for loop contains an even number, and I have to append it to the L list. L append method I. And at last, the one function will return the L list. Very simple. And now I want to define second function and name it, let's say, 2. Local variable L here equals to I start list comprehension, and inside square brackets x for x in range 10,000 if x modulo 2 equals to 0, and then the 2 function will return L variable. These functions work and we can check it. Print 1, print 2. I run the script. 2 lists with even numbers from 0 to 10,000 here. Okay, we have made sure that our functions work well, and now let's count the time of work of each of them. To do it, I import from the datetime module the datetime class. From datetime import datetime. And to count the time, I will use the now function that returns the current date and time with a millisecond precision. And at the beginning of each function, I'll create a start variable that will accept the following value: datetime module dot now. I'll copy it and paste it here. And at the end of each function, before returning the result, I will print out the difference between datetime now again and start variable, datetime.now minus start variable, and copy this line here. Run the script, and thus printed out value will be the time spent by these functions. Let's call our functions again. I create L1 variable that equals to 1 function, L2 variable equals to 2 functions, and I start the script. And we have seen in practice that list comprehension works faster. Also, the L1 and L2 variables contain lists of even numbers. We can see that if we print them out. Print, let's say, L1. This code is the basis for reviewing the work of decorators in Python, because at the same time with the solution of this problem, measuring the time, we have encountered two issues. The first issue: we have violated the principle of single responsibility of functions. Besides filling or generating lists, our functions also count time. And the part of the code that is responsible for the immediate solution of the problem, generating lists, has to be found among the code responsible for measuring the time. And this is especially clear in the second function, where the list generation takes only one line, when counting and outputting time takes 2 lines, here and here. The second one: I have violated the dry principle when wrote the code for counting time. Dry, as you know, stands for don't repeat yourself. In fact, we have copied these 2 lines, 1 and 2, in 2 places. If we need to count time for 10 functions, we would have to insert manually this code into 10 places, and it is not convenient. Okay, and what can we do with it? I think you will agree with me that it would be very nice if there was some magic function like the print function, where we would send our function and it would count spent time of the function for us. And the good news is the Python language has a syntactic construction that allows us to do such a thing in a similar way. And this syntactic construction is decorators. Let's write one that will count time for us. But before we start, I want to remind you that functions in Python are the first class objects. This means that functions are real objects that even have their own methods that can be assigned as a value to variables, that can be sent to another function as an argument, like it happens with the map function, and we can return function objects as a returning value of another function. And at last, inside the function, we can define another nested function. And now I'm going to write a simple decorator. I define a new function with name, let's say, timeIt, and the function will accept any other function as an argument, and its argument I name just func. As the result, timeIt function will return another function which I name, let's say, wrapper. Return wrapper. The timeIt function returns the wrapper function as an object. That is why I don't use round brackets here, because using round brackets means I'm calling the function. And now inside the timeIt function, I have to define the wrapper function, def wrapper. On its turn, the wrapper function will return some result variable. And here I have to define the result variable. Result equals to, then I have to call the function. Here at line 5 I just get a function as an argument, and here at line 8 I just have called it and executed its code. It is a basic frame of our decorator. Right now we have finished it. And now we can add to this decorator some specific functionality as we intended to do. The decorator will count a function's execution time and will return a result of that function. And to count execution time of the function, I just copy and paste these lines here at the beginning of the wrapper function, and this one at the end of the wrapper function, but before the return keyword. Then I delete these lines. And now I have to call our decorator. I can do it with the @ sign, and then I have to specify the name of the decorator function. Time it here and here. I run the script, and we can see that all works as before. Our L1 and L2 variables contain lists of numbers, and we can see spent time here. All works. And at the same time, we have achieved accordance to the single responsibility principle. Our functions 1 and 2 are containing only appropriate code. And at the same time, we have rid of a code redundancy and our code became more dry. Okay, the next step. As you know, functions can accept some arguments. And I'd like to change our code to support ability to send some arguments to these functions, 1 and 2. And then I'm going to reflect the changes in our decorator function timed as well. I am adding to the function 1 and 2 an argument n, an integer number, that generator range will use to generate a sequence of numbers. In the decorator, I reflect the changes in the functions in the following way. In the definition of the wrapper function, I add arguments with star sign, args, and 2 stars and key W args. This syntactic construction stands for the function wrapper is now accepting some positional and keyworded arguments. And then I send these positional and keyworded arguments to the function. And this is the case when we don't know what arguments are accepted by the wrapper function. These arguments are never used here and just immediately sent to the next function, to the function. And the wrapper function works here like a pipeline. Now I'd like to check if the decorator is working. To do it, I just send to the functions 1 and 2 some numbers. Let's say it will be 10 and 20. I run the script, and we can see that everything works as we expected. And now I want to comment out my timed calls, and I'd like to review how the decorator timed is working. Then I create an a variable that equals to the 1. 1 is our function without brackets, because if I specify the round brackets, it will be the call of the function. I don't want to do it, I just want to assign the function object to the a variable. And then, if I send to the a variable an argument, let's say 10, I will get the list of even numbers from 0 to 10, because the a variable is referencing to the function 1. The next step, let's create L1 variable that equals to the timed function with the 1 function as an argument. And now I print out type of L1 variable and its name property L1 dot underscore name underscore. And we can see that a print function shows us that L1 variable is a function, and the name of that function is the wrapper. Why so? Because the timed function returns the wrapper function with all its context. So it looks like this. Timed with 1 as an argument returns the wrapper function. And as this expression returns us the wrapper function, I just send 10 into it as an argument. Print L1 and run the function. And it's working as we expected. We have spent time and we have a list of even numbers. So, timed with 1 function as an argument returns wrapper. I have sent 10 as an argument to the wrapper, and the wrapper function returns func function with 10 as an argument. The timed function got 1 function as an argument, and 1 function was assigned to the local variable func. Then timed function returns the wrapper function. Wrapper function got 10 as an argument. Then wrapper function count time. Then wrapper function calls func function, and the value of the func variable is the 1 function that got arguments of the wrapper function. And at last the wrapper function returns the result of the func function with 10 as an argument. And this part of the expression returns a list of even numbers and print out the spent time. And we have made sure that our decorator is working. And the @ symbol that we have used to call the decorator is just a syntactic sugar for this expression. And the last situation is when a decorator accepts any arguments itself. You could see this when used the Flask framework and used its decorator route to bind URLs to a certain view. It looks like this. app.route some URL here, and then some view function, where app is an instance of the Flask class, the route method is the decorator that accepts its own arguments, and at the same time the index function can have its own arguments. So, how to implement a decorator that can accept its own arguments? And to implement this, I have to wrap or nest the wrapper function of our decorator to another additional function. So here I define a new function, let's say order, And the timed function will now accept some arguments, and auto function will accept func function. The auto function on its turn will return wrapper function, and timed function will return auto function. Timed returns auto, auto returns wrapper, wrapper returns the result variable. I don't know for what to use the decorators argument, and just print it here, arg for instance. And I'd like to specify an argument for timed function. Let's say it will be hello, and here it will be world. Comment this out. L1 equals to 1, 10, L2 equals to 2, 12. Run the script, and we can see that arguments of timed decorator was printed out, and we have seen spend time of our functions. And the decorator timed works in just the same way as above. I comment out call of decorator. So timed function accepts an argument hello world. This expression returns auto function. Auto function accepts the one function as an argument. On its turn, auto function returns the wrapper function. We have sent 10 as an argument to the wrapper function. And then the wrapper function calls func function with its arguments. I run the script, and we got hello world as an argument of timed decorator. The spend time that was calculated within the wrapper function, and we got the list of the even numbers from 0 to 10 that was generated by the one function. So decorators is a not so complex concept as it looks, and it used to make a code clear and to avoid code redundancy. If you like the video, please like it and subscribe to the channel.